presentation. So I'm delighted to talk today about the topic of resilient smart cities. And well, the question I'm starting with is, have you ever rebooted a digital city? And well, this might be what you see as a well, first event if something goes wrong currently in your systems. And we definitely do not want to see this if you run digital cities. So let's just have a bit of a thought exercise. So what is the meaning of a system crash or a successful cyber attack? And that can vary very widely. So for example, for your PC at home, well, you might lose your holiday photos. For your servers in the office, you might not be productive, or well, product launches might be delayed. For servers in a hospital, that might mean that patients cannot be treated. And then if we move on to embedded controllers or autonomous cars, there can be all kinds of, well, mishaps happening if a system crashes, if there's a successful cyber attack. And now envision all those things coming together, like a digital city where you will be living in, where there are embedded controllers, where there are autonomous cars, where there's like, well, electricity power plants, there's hospitals, there's you, there's your other citizens. And well, that can have severe consequences. And now if you in a first step thought about just a system crash, something going wrong, now think about some ransomware hijacking parts of this city, or think of some more sophisticated cyber attacks really targeting some of the critical utilities. And you realize that, well, this is not the most, well, promising perspective, let's say. So let's have a bit of look into this. So during my keynote today, I'm going to talk about first trends and promises. So what are digital cities offering, or what do we envision digital cities might look like? We are going to look into some challenges. So what if those digital cities are challenged by crisis, catastrophes? We are going to look into some ways forward. So what could be solutions, or what could be, well, not really technical solutions that you could directly apply, but what could be principles to build digital cities on, to make them more resilient. And last but not least, we will have a few minutes for discussion if you have any questions. So let's get started with trends and promises. So first of all, there's this trend to urbanization. So we have more than 6 billion people living in cities in 2050. This is at least what the UN prognosis is. And we have roughly 9 to 10 billion people living on this planet. So most people, 2/3 of the world population, are expected to live in cities not too far in the future. We are currently within a digital transformation. So we have close to 5 billion users using the internet. We have close to 6 billion users having like a mobile phone subscription. And we have, well, billions of gadgets. There's a number of estimates, nobody knows the exact number, but the Internet of Things, which is also part of this workshop, has more than 20 billion devices connected. At least this is an estimate. And well, looking into digital cities or smart cities, one could say now this is the intersection. So we have urbanization as one trend, we have digitalization as another trend, and well, the digital city is just sitting in between. But I think this is not, well, this is not far enough ahead from our thinking. We have to see future cities as digital cities. So cities will not be analog to a large extent, but they will have digital components, they will be hybrid, and future cities will have to be digital to be sustainable and to cater to their users, to the citizens. So what is my definition of a digital city? For me, a digital city is a complex networked cyber-physical system that is formed by the extension of existing physical functions and activities of a city by means of digital spaces or cyberspace. And this is ultimately enabled by information and communication technology. And in the end, we are going to offer an abundance of digital services on top of the existing services. Well, and with this, we can get a couple of promises. So people say, well, these cities can be sustainable. mobility, everything will look very, very nice. For those promises, let me go a few hundred or a few dozen years back. So there was like a group of French artists in the early 20th century, around 1900 up to 1910. And they were basically producing their vision of what the year 2000 might look like. And that was a set of postcards. And now the next couple of pictures are basically how people a bit more than 100 years ago envisioned future cities to look like. I mean, they had thoughts of smart mobility in a sense. And if you look in a city on all these, all those gadgets you currently have to move around in a city from whatever company, this is not too far off, I would say. Smart homes, well, there were robots envisioned that would clean your home. Today, they are even a bit more autonomous than you see in this figure. There was video conferencing envisioned. We had visions of smart farming. And lastly, from this stack of postcards, there was a vision of how future mobility like air taxis could look like. And again, this is something we're currently discussing. If it makes sense or not, this is not up to me to judge. But still, I mean, 100 years ago, roughly, people had some imagination, some vision how a future city could look like. And with quite some of those, they were not too far off, even if the implementation now is probably wireless instead of wired. Some of the details they obviously got wrong. Now looking a bit closer, in the past few years, we also had like initiatives looking towards smart and digital cities. So for example, the Alphabet as a company had this idea to transform parts of Toronto. And there's quite a bit of information online on this. And they looked at also some of these critical services of cities. Like, for example, they were looking for a mobility system that is safer and more convenient than private cars, and it should be coming at a much lower cost. They were looking at how to re-envision housing and real estate and to make it more adaptable to different use cases. So cheaper, more efficient, more affordable, and being able to switch uses while you were living, and basically repurposing also housing. Sustainability is one major goal, or was one major goal for this transformation. Like, all the utilities should just be invisible to the users, and on one hand, on the other hand, everything should be like, well, friendly to the environment, sustainable in all kinds of senses. Users or citizens should be in the focus of the attention. So there should be a public space that's usable all year round. They even basically envision that we have, or that they will have heating outdoors, basically, so that people could have sidewalks that are heated in winter from renewables and so on and so forth. And last, but most important, well, this was driven by Alphabet, by the company behind Google. They said, well, we need an open digital infrastructure to bring innovation and to enable all those services. That was a huge project, and it was canceled like roughly, I think, 18 months back. And for a number of reasons, like privacy was one concern, but in the end, Alphabet said, well, the financing is unclear to us, and it's going to be too expensive. But in any case, the ideas they had, and digital at the core, or digitalization at the core, was basically giving quite a number of ideas to city planners and other people. So now, looking into digital cities, however they might look like, from a challenges perspective. And with challenges, I refer to basically external events, extreme events. So for example, that could be crisis, that could be terrorist attacks, that could be, well, natural disasters like the recent flooding we experienced in parts of Europe. That could be blackouts, or that could be other utilities such as water supply. And staying here like for a few seconds on this slide, For example, in Germany, the Lake Constance is supplying roughly 4 million people with water. So if it would have not enough water, or if it would be poisoned, you name it, 4 million customers would be at risk not having any water in the southern part of Germany. Blackouts, I mean, we've seen huge blackouts. If we are in urban areas, dense urban areas, having people losing access to power for a day, half a day, or, well, in the worst case, more than a couple of days, will have tremendous consequences. All kinds of other utilities depend on electricity. So communication is not going to work. Finance systems are not going to work. So huge consequences due to network effects if electricity fails or if information or communication technology fails. And then, well, natural disaster, terror that cannot really be predicted. But we also have digital disasters in a sense that could hit us. So for example, ransomware is something that we've currently seeing all over the place. And like 3 years back in 2018, there was a very well covered incident in Atlanta. So the original ransom was like around $50,000 US. Atlanta spent in the end more than $2 million to recover from this, to rebuild the entire systems and try to make them, well, much more robust against this type of attack. And if you then look on, in 2019, this accelerated. Currently, this is also really, really accelerating. So ransomware is something that we have professional actors here. You can hire basically services, ransomware as a service, more or less. And well, we are seeing all kinds of public services, public utilities not being adequately protected, despite the fact that this is sort of a threat or an attack vector that is rather well known. We still don't have technical solutions to this, or most of the technical solutions are not properly applied. And well, in the end, you run into those problems. Now, if we summarize these challenges or crises for digital cities, we have an increasing complexity of crisis, of unexpected crisis in today's complex and networked societies. And that might be natural disasters, that might be cyber attacks, that might be blackouts, terror, or in German we have this term Allgefahren, which means basically all kind of dangers. And so essentially this is what we should be protecting against, all kinds of dangers. And now if we look into traditional and risk-based approaches, they are typically insufficient in those kind of scenarios. So we cannot just protect against all kinds of those incidents, of those crises, and it would also be prohibitively expensive. So therefore, what we need is essentially a paradigm shift. So I argue that we need a resilience-based approach. And that's also because, well, in this title I was starting with, let's reboot a city, or can you imagine how to reboot a city? Rebooting a city will not be a viable option because it would take too long. It would probably not work smoothly, and we would run into all kinds of other issues. So now, what do I mean with resilience? So what is resilience, and how could you have sort of a resilient system in the area I'm talking about? So for me, resilience, and this is the definition I worked on with a couple of colleagues, for me, resilience describes the ability of a system to either absorb crises, to cope with them by recovering in a timely and efficient manner, or to cope with them by attaining comparable or a new basic functionality by means of system adaptation. And let me give an example to make this a bit clearer. So just envision sort of a tree. Well, there could be wind. If this tree is sort of tough enough, elastic enough, can adapt to this wind, well, it will just absorb this wind. If the wind is gone, it will typically recover. So this short-term coping with crisis or external stress and shocks by bouncing back to the original state, you can reach by hardening the system, by making it tougher, increasing elasticity. But there might be, well, more wind, And this might lead to the system not being able to bounce back. So you might have to long-term cope with this situation. So you might have to bounce forward to a new desired state. You might have to support the system externally. You might have to substitute parts of the system. So if this tree breaks, you will want to eat some fruit. Well, better plant some shrubs or some other plants that give you fruit and that can tolerate this level of wind. And then the sustainability comes in here by learning from this experience and by continually improving and maturing the system. So you essentially have like a resilient cycle where you constantly want to improve this system and constantly learn from what you experience, so that if this event happens again, the system can deal much better with it. Now, this also reflects in a disaster management cycle. So if you have like a crisis hitting, that's like the red event shown here, the system will deteriorate. Hopefully, if it's resilient enough, it will not go to a dysfunctional level, and then it will basically go back to normal level. So if you have a system that has been designed to be resilient, you would want to be tough to absorb as far as possible this shock, this crisis. You would then to try to adapt, recover, transform the system to be as fast as possible, again, back to the status quo level. And you would want to learn and strengthen the system so that if another shock comes, it can deal even better with this. So now, what is ways forward? So how can we now start looking into building a more resilient systems, complex network systems such as digital cities? And this is where I would want to, well, give some ideas, some hints, what are possible ways, and also would want to give some examples to make it a bit more tangible. So first of all, the vision we are working on together with a couple of colleagues here is resilience by and for ICT. So essentially, if your ICT is not resilient, you will have a very hard time making use out of it to have a more resilient overall system. So we are actively investigating how to build, how to design, how to operate resilient information and communication technology. And if you have this in place, you can use it as a tool to increase the resilience of whatever other system that's empowered by ICT, for example, a digital city. Now, what is typically happening if you add ICT to whatever process? So digitalization happens all over the place. So you're in normal operation of a system, you start digitalizing it, and then you will having basically a consolidation. For example, you will have efficiency improvements. You can move to just-in-time production. So we have quite a number of, well, benefits from digitization that we are currently also, well, realizing. So inefficiency can be effectively removed by digitalization. So we can now communicate. Our supply chains are much faster. We can have just-in-time production, as already mentioned. So therefore, we do this extensively. We save tons of money at certain points where digitalization really hits. But while digitalization itself costs a bit, but anyhow, it helps us to make our processes much more efficient. Now, something we often forget is that digitalization can also make systems fragile. So efficiency and resilience are not the same optimization goal. And I firmly believe that we need to think longer term, that longer term and sustainability for such digitalization processes are really crucial. So let me give some examples. So for example, inefficiency and slack in a system has a value. So overcapacity or, well, adequate capacity in a sense. So we do not want to waste resources, obviously, but sometimes it makes sense to just have a system to have a certain overcapacity. If you would run a web shop and this web shop is, well, built such that it can handle the average load of some customers, well, in the Christmas period, you might not be the most lucky vendor of whatever, because your web shop will be overloaded. So you have to provide enough capacity for such events. Now, providing capacity for events that you cannot foresee, for crisis, can be really difficult. So therefore, what you would want to do, you would want to add strategic overcapacity so that you can deal with a certain, well, outage of parts of your system, or that you just have sort of enough to deal with some unforeseen event. Redundancy is something that is often overlooked. So, and redundancy can be very simple to realize in the digital world. So you can just clone your service in a sense. So now you have a cluster, and the cluster is, well, handling more workload, but you would have to do this really strategically. So redundancy is also something that, well, is just costing, so that it's more expensive. So if your network provider for your mobile phone service would offer you a new contract and says, well, if you pay whatever, €5 more each month, we will have a more redundant service for you. I guess many people will say, well, how often does it not work? Well, it's not too often. Why should I pay more? I go to the cheapest service that's there. So many people will just select with this price, and redundancy costs, and not necessarily, and you will not realize it until there's sort of a real problem. But how often are those emergencies? So, well, why should I pay for it? So to get strategic redundancy, you will probably need a bit of regulation. So for example, there's a building code here in Germany. If you have a public building, it has to have independent fire exits. So, well, it's cheaper to build a building with a single fire exit, but we've seen that it makes really sense to have independent staircases and independent fire exits. And people do it because there's a bit of regulation, because you could do cheaper, and in case of fire, you would have a problem. So, well, with a bit of regulation, you can enforce redundancy. And then there's, again, a fair, well, competition again, because everyone would have to provide redundancy. So for certain services, forcing redundancy appears to be really sensible. But redundancy as such might not solve the problem in a case of a cyber attack. So if you have, like now, redundant servers, maybe even in redundant data centers, and they all run the same operating system, there might be a cyber attack just taking all your redundant systems off. So here you would want to have some strategic heterogeneity. So maybe some Linux servers here, some Windows servers there, or just like a system that is diverse or heterogeneous enough to not have such a unified and narrow attack surface. So therefore, well, I'm going to, there's trade-offs involved here, but essentially you want a system that is not like easy to shut down in its entirety. And therefore, diversity can help. Openness is very important. So if you have like systems, be it in the IoT, be it in smart cities, if the system is open, you can much better assess the system properties. So you're not relying on some black box that you can't just look into. And in case of well, crisis, you could try to fix this system because it's open and because it can be fixed. However, there's a trade-off. You have typically a trade-off between diversity, redundancy, openness, and security. So IT security, your attack surface might increase if you now, instead of having like one system, multiple diverse systems. If you have an open system, some adversary, if it's open for the adversary as well, like in terms of source code, they could also look for security vulnerabilities. Well, you could also look, the good ones can look, and the bad ones might be able to look. So openness, you need to be a bit careful with this, but in general, openness for a number of application domains is a rather good idea, in my humble opinion. Programmability, repurposing, and software definedness, I call the next, well, next step or the next idea. So having programmable systems can change a lot. So we've seen that programmability is really part of the success. If you look at smartphones, the openness of Apple to say, like, everyone can bring an app and we have an ecosystem. So Apple is not the most open company, but these apps, the programmability for the phones was basically spelling success for this domain. And therefore, I firmly believe that in the Internet of Things, in smart cities, we are just at the beginning. We need ecosystems that are open and that allow people to make use of the data we collect and sense there, and to have basically applications that bring innovation. And now if you have those systems and if they are programmable, they are much more flexible. You can now repurpose them. And you can essentially also, if the system has a dramatic change, a crisis, you can basically adapt those systems to deal with this. And well, in software, this is much easier than if you would have to replace analog systems, if you would have to replace hardware. So therefore, programmability can really help a lot. Decentralization and recombination is another major factor. I would want to see in those domain systems that can fall apart if there's some external incident, stress, crisis, whatever, that can operate in a decentralized fashion and that can later on recombine. So centralized systems can be much more efficient and work well with much less resources in many cases, but decentralized systems can be better hardened, can have a better survivability, dependability, and this decentralization can have a system continuing operation even if the central components failed or are under attack. So if we depart from centralized systems to hybrid systems that work in a centralized manner in normal operation to have like all these gains of efficiency gains and well, gains of central orchestration, then this should be a good direction. So if we have systems that can disintegrate in a sense and later be recombined and operate decentralized, as long as there's this external attack crisis whatsoever, that would help a lot. And well, last but not least, try to keep those systems simple. So we are currently adding and layering systems of systems on systems. And this complexity is very difficult to control. So some whatever old protocol breaks and suddenly huge parts of systems in the internet that still have it somewhere embedded have some problem and need to be fixed. So for some of those utilities and core functionalities, my advice is really try to reduce it to the core functionality of the system, try to keep those systems simple. That brings me to a short summary. So I've been talking about, well, what are potential risks, problems of smart and digital cities? I tried to give you a couple of, not necessarily tools, but ideas on how to build those systems better for the future. And to reach resilience by design, or to design systems such that they can survive crisis, we have a couple of things we should do. So we should not only look at efficiency, which we typically do, we should also look into resilience and dependability of these systems. We might have some regulation, we might require a framework, we might need some governance from startup to get those systems. And then optimizing efficiency under those resilience constraints will still give us efficiency. Heterogeneity, diversity, adequate capacity can help a system. Openness and complexity of systems is dangerous, so we should remove it. We should have open interfaces, we should have open software, we should have open hardware, and that allows and facilitates organic growth and sustainable growth of such systems. We need to get a bit more technological sovereignty here in Europe. We need to have more simple systems for some of the applications we are running. And well, then there's some emergency capabilities I would want to see in each and every networked systems. I'm not going to repeat this in interest of time. Thank you very much for your attention, and I'm happy to take a few questions.